In this lesson, we are working with scatter plots and correlations. We are talking about looking at creating a scatter plot, how we can find and interpret a correlation, which is relationships, and determine what type of regression that is the scatter plot. So we've talked about scatter plots before, but here are some examples. Remember that a scatter plot is a set of plotted points that show the relationship between two sets of data. For example, if we take a look at this first scatter plot, it has a relationship of weight versus height. And as we graph the points in this scatter plot, it's showing that the heavier a person gets, in general, the taller the person gets. According to this scatter plot is what it's showing. We have a couple more examples where we also have a scatter plot of relationship of points, and you'll notice as we look at this one as well, and as we look at this one, that there does seem to be a relationship between these points. And this relationship looks like it is pretty close to being a line, and that the points center around that line. So our job is going to be to look at if there is a relationship when we have a scatter plot that is linear, or is it possible that there will be a relationship with the data that has a curve. And since we just had our last unit on exponential growth and decay, we'll take a look at some of those types of graphs. The line or curve of best fit is a line or exponential curve that can be drawn to fit the data set, and we are going to use that line or curve to make predictions about information or data that will be coming. So if we take a look at this first set of data, it looks that if we were to draw a line of best fit through the data, that it would be going down. Or if we were to draw the curve of best fit, it looks like that this would be one of exponential growth. Let's take a look at some examples and relationships. First of all, let's take a look at linear relationships. Remembering that with linear, we are basically looking at and referring to the slope of the line. So if the data that we are given in the scatter plot has a positive relationship, which is a positive correlation, it would look something like this. And it would have a positive relationship because the line of best fit drawn through that data would be going up to the right. If the linear relationship were to be negative, that would be looking at a negative slope, and the data would be centered around a line that was going down to the right. That would be the line of best fit having a negative relationship. Now, if we were talking about an exponential relationship, thinking back to our last unit, we would have an example of the first one being growth, where the points that we would draw would have a relationship of going in an exponential growth pattern. And if we had exponential decay, the pattern would be going down. So let's take a look at another term called correlation. The correlation tells how strong the relationship is between the two data sets. We are going to use some technology, possibly the graphing calculators, to find this relationship. It is called the R value. So this relationship determines how closely the data is to that line. If it has a perfect negative correlation, that would be an R value of -1. And that would mean if it is linear, that data set would be exactly on the line. No points would be off the line. Likewise, if we were doing an exponential decay, so that would have a -1 relationship. That would also mean that every point that were to be drawn on that example would fit exactly on that curve of best fit. If the correlation were still negative, but it were not a perfect negative one, then we would have the relationship be close to the line of best fit, but there would be points that would not be exactly on the line. Likewise, the same with the exponential decay, that the pattern would be one of decay, but there would be points that would not be exactly on the curve. Now, what if there is no correlation, no relationship? That means our data is scattered about. It wouldn't be linear, it wouldn't be exponential, there would be no relationship between the data. Now, if we have a perfect positive correlation, and that would mean the R value is 1, then if it were linear, those points would be exactly on the line. None of the data would be off of the line. Same thing if we had an exponential growth model. That data would all be exactly on our exponential growth curve. However, if it were positive but not up 1, then some of the data might be on the line of best fit in the positive, but there would be data that wouldn't be exactly on the line. Same thing with our exponential growth model. It still would have the pattern of growth, but there would be data that would not be exactly on the curve. Let's review. Scatter plots can be linear or exponential. The correlation ranges from -1 to +1. -1 being a perfect negative relationship and +1 being a perfect positive relationship. 0 means that there would be no correlation. In class, we're going to create and interpret scatter plots and take a look at their correlation. Please remember to complete the reflection.